All right, so hello everyone again. I congratulate this group of builders, group 4, for the hard work for last 3 months. Again, just to remember, there are 5 assigned electors who will be evaluating your project submissions plus these recordings and the presentations, and then they will vote on your delivery, and you will hopefully get the results on 26th January. So let's start with Berkin. Its stage is yours, please.
Okay, hello everyone. It's our project ZK Apps Umstad. It's an AI agent for ZK Apps developers built by me and Doğukan. I can start the slides show. Okay. We have actually two products, as you know. The first one is the web application, zkappsumstad.com, and second one is the CLI agent. It's an advanced CLI tool for project building. First one is actually, it's a web application chatbot. It assists developers with ZK Apps, O1.js, Mina protocols, write smart contracts, debug troubleshoots, daily queries, ideas, etc. Also uses multiple tools. Also has access the Discord discussions, external sources. And the CLI agent is advanced tool. It's working locally. And also you can download from PyP with pip using pip install ZK App Umstad, and it uses multiple advanced tools and states. Also, it uses same infrastructure with the web application. Okay. Our project has multiple purposes, impacts, and benefits. It's quite to streamline, simplify the development on Mina. As you know, it writes code, it solves problems. You can ask ideas, especially for hackathons. You can ask about ideas, project ideas, or you can ask about anything about the Mina. It reduces the learning curve. Actually, because it can create tutorials or it can simplify the learning process for especially beginner developers. It's first address for developers, I think, just before the Discord channel. It answers all kind of questions from beginner questions to advanced questions. It enhances ecosystem growth. Also, it helps to onboard and attract more developers. For example, suppose that you are in a hackathon. When you want to build a Mina project or ZK apps, you don't need to scan all documentation, all examples anymore. You can just use our ZK Apps Umstad, and you can get specific information, or you can solve your problem anyway. And it has Discord and GitHub data. It has ZK Apps questions and ZK Apps developers channels information currently updated, and you can just start with I have an issue, blah blah blah. It will query to the vector DB and get the Discord discussion and answer if it exists. And also it stays updated. We can, or I can, or anyone can, if I give some credentials, anyone can update the all information within 5 minutes, process, download, and upsort it. Also, it provides debugging and automatized debugging with CLI agent. Our AI agents components exist of strong Pinecone vector DB. It has 4 kind of vectors. First one is documentations or any verbal or written sources like documentations, Mina blogs, or Mina book. And also it has code examples from tutorials and some perfect smart contracts, just giving code snippets. Also, we have project database. It includes most of the zkIgnite or hackathon or recently built projects. Also, we have a special vector, issue vector. It has GitHub issues and Discord data. Also, it uses tools, OpenAI tools. In the CLI agent, it's working like a state machine. Doğukan will explain later. And web app also uses tools linearly, and we also use OpenAI API, and also we use Next.js API on Versal for retrievals. So can continue to explain.
Okay. Here you see architecture diagram for our CLI agent. You are sharing your entire screen. Can you move it to the left or right?
Oh,
No,
okay.
just the text.
Is it okay now?
Okay. It's in the CLI agent, there is still a chatting structure, chatting flow, and it starts with the user input and chat agent state starts. It has an architecture like it can have multiple states, but now it has two, regular chat agent and coder agent. Coder has a simpler prompt for coding, but chat agent has a complex prompt. And chat agent starts with its runner function. Its runner can decide to answer the question directly, or it can decide to use retrieving tools as Berkin declared. Doc retrieval tool, code retrieval tool, project or issue. It can retrieve multiple queries. So it can learn 2 or 3 terms from the documentation. It can fetch data from code index, or it can ask questions to issue index, so it can query from there. Then after it thinks it is enough to answer the question, it answers it in a text format. But if it needs to build the code, it passes the state to coder agent, so state transition. And coder agent starts with searching code examples like the code retrieval tool. Then it reads reference codes we supplied. It is a simple contract and its test. Then it starts the build loop. It has maximum iteration number, so maybe it will fail after some iterations, but expected scenario is it starts with writing the code, then it builds it. If the build is successful, it writes its tests and continue give an output to user. If it fails, it searches it in documentations and issues. Issues includes Discord forum or GitHub issues. And it looks to references in the Mina O1.js documentation. So if it is about using a function or using a class, it solves that issues fastly. Then it writes the code again. And the loop continues until a successful build. Then it tries test, then output to user. The flow is like that.
Okay, if you have any question, we can answer about that. If not, we are going for sub-projects. Also, we have helper and sub-projects for building our agent. First one is uploader project. It used to split, load, process, and upsert to the vector database for any kind of sources. And second one is the Discord. This was the most difficult project for us, and it provides getting to Discord threads and process it and upload it to the vector database. Also, we have thread uploader for Discord moderators or for me. For example, we have currently latest recent discussions in the Discord, but 1 month later, it will not be in the vector DB, but by using this thread uploader, Discord moderator or me, I can just get the latest discussions, download this discussions, and process it. And after that, I can upsert to the vector database. Then I can update the issue DB with within a 5 or 6 minutes with a few commands. And also, our new project is Discord Umstat. It currently uses Discord chat interface. It's in the build phase. It currently uses chat interface, but our main goal is that using the slash command in the Discord channel, for example, someone open a thread asking a question, and someone just calling the umstat with slash command and waiting for answering the question. It is to do project now, but we have a chat interface currently. Okay, it's demo time now. It is our interface, and you can ask anything about Mina 01JS smart contracts. We can wait for you, or we can ask about it. Let's go. Who wants to try? If you want to try, I can ask something. Let's go. No?
Let's ask about nullifiers, how it works, for example. Yeah.
Okay, first Yasin, because he talked after the chat.
I think, yeah, I am asked the same question.
Okay,
So,
okay. Yes.
nullifiers.
Nullifiers and or just it
Yes.
Mina or 1JS. Okay. We have also chat history here. You can get your previous chat history. Also, we have settings page. I will show it. It gives GitHub issues and papers. We can just look to the.
Interesting. Yeah.
It's referenced this and this paper. Yeah. Okay, we can ask. Okay, we have what is account update?
I am there. It's a website, so you can like easily. If you Berkin, can you send the link of the website?
Ah, okay.
It's not a local host.
No, it's working.
It's live.
Yes, you just log in and you can use it. If you don't want to log in, or if you don't want to use for any reason it, we provide an API. I will explain later. Okay, you can see the answer. Maybe I can make him to write smart contract. Um, Also, I will show to query Discord data. And if you want, you can select, or I can select any discussion from the ZK Apps questions channel, forum channel. Okay, now currently we asked about creating smart contracts for specific purposes, and it's planned by using several tools. And it's now, after planning it, it's going for implementing. And it's now got the documentation information, example projects, code snippets, and now it is writing the smart contract now. There may be a few mistakes, but it gives the outline and some usage like that. Do we have any? Okay. Okay, I can show the how to okay, now CK apps questions. Oh. You can select or I can select, but it's currently now the sold or after 7 days. If it is sold, it's in the database. If it is not sold and recent, it is not in the database. You can just select, or I can select randomly. Do you have? Okay. Oh, okay, I'm selecting. Don't you want to? Okay, let's go for it. I think it is enough. The tricky thing is to query to issue DB. Just start with I have an issue or problem or error, something like that. And it will use the issue tool. And it's querying now. We can just see the answers, the discussion. And it's processed already this discussion and question answer, and it got the context and writing it. Oop. What is that? Also, we can query about other thing.
And there is a question from I am there.
Okay, can you deploy zkApp smart contract without? Okay, ask. Is it correct answer? I don't know about that, but I think it's provided a project, project from Mina ecosystem, right?
He says the AI mentioned my project.
Yes. Okay, good for him then. Okay. Also, you can ask about the current blockchain status. Ask what is, okay, provide me current blockchain summarize. I think I asked wrong, but let's wait. It uses the Mina Explorer API and gets account or anything. For example, let's go for it. Okay. Also, I implement asking about Mina price, but it works locally, but it cannot query on deployed to the website. There is a problem about that. Now you can see the current blockchain summary. Okay. You can also ask about balances, etc. You can try it. We have less time. Just going for the CLI tool. Are you ready? Or we have, okay. Okay. Now you can see my terminal. I just created a zk project by using zk create command. You can download this CLI tool from pip install zk. It requires Python 10. And let's work with it. Okay. Now you can see recently created zk apps project, and I just remove these files. Now, who want to make the AI write the code? zk install start. Okay. Okay. I'm ready if you want to ask something, or if you want to use it, make him write to smart contract. We can write it. If you want, I can write. Is there anyone who wants to try it? No. Okay. Let's suppose that I want to build a hackathon project which is about verifiable credentials. All features are up to you, because I don't want to spend time about that. For your information, it is not very stable. It can create very wrong contracts or can create very good contracts. But after writing the contract, it uses debugging tools and just debug the errors for you. Okay, it's planned the project like that and provide the information to us and asking about changing state and write the code. Now it got the code examples and reference code, which is Sudoku contract currently. We would like to change it, but currently main example is that. Yes, it wrote a smart contract, create a file like that. And there are errors. And now it's trying to solve them. Now it will update the contract. This loop continues up to 5. You can change it, but I think 5 is enough because after 5, the contexts would be more crowded and it will affect the code quality. Now it wrote kind of different and there are errors. Also, you can copy and paste your contract here and just ask about debugging. It can do that automized and it can handle the most of the errors. Oh, now it build it. Uses some wrong things, but now it's built it. Will succeed. And now it writes the test of the contract, but it's not writes the very long, detailed tests because we don't have the very long test database. Look that, and it creates something, and now we are done. You can also save your conversation as a README and or reset and okay, we don't have time. Quit. Okay, now do we have time or can we continue? Yes.
Yeah, you can continue a bit like.
Okay, we had challenges and their solutions. Unexpected thing is unlearning. Currently, GPT has a lot of Solidity and other smart contracts logic. And when you ask the smart contract, it gets as a smart contract. we ask, for example, don't use the constructor. It always uses constructor, but thanks to Yunus, he wrote a very good essay about provable contracts, and the essays the essay summary, we added some prompt. We added it to the prompt, and it is magically solved, and it writes the smart contracts as zk circuits. So we had, after the latest update of the GPT, now it has the information until the April 2023. And because of that, it has Snarky.js information, but very old Snarky.js information. It always used depreciated codes, Snarky.js, and this was very difficult to solve it because unlearning to AI is very difficult. But we solved it very tricky. For example, it uses a constructor, await is ready, or some depreciated codes. Even we added depreciated codes, looked at, and you don't use them, it uses. And I add the prompt last sorry, my focus just gone. Okay. I add a swear prompt. I wrote just, if you use them, you are son of a bitch, and now it stopped to using it. Yeah, it was very tricky, and it was great engineering skills, and but it is useful. Also, Doğukan encountered some challenges and solved them very brilliantly.
Thank you. It was going in endless loops, especially in the CLI, because it is writing code. It's a long process, then it fails or decides to write it again and again, like that, or it queries the same thing or some terms again because it doesn't find it useful enough. So both increasing the quality of the data and some optimization fix that. It is using two states after that, because an agent with too many tools is like just an agent that tries everything but does not do anything. So we splitted it into two states, and it is fixed. It can query from everywhere, then decide to code. It can write it, then again turn back to chat agent state. And long context were confusing the agent, and it was increasing the cost, both time cost and money, API cost. So we have an optimized retriever. Both our data is optimized and our parameters are set for that. So it has smaller context but more accuracy now.
Yes. Also, for optimization and evaluation, we built eval.
Yes, we have evaluation tool for our project 2. It's under the same repo under eval folder, and our references were OpenAI's eval and human eval repos. They have some data set and some evaluation method. They have a paper evaluating large language models trained on code. We took them as reference, but we built our evaluation code ourselves. You can see the comparison here. GPT-4 is better than 3.5, but ours is much more better than that in terms of accuracy. But if you look into latency, ChatGPT 3.5 is the fastest. Ours is like 13x. It is too much smaller because it uses tools, databases. Then it returns the answer. The evaluation actually is a part of our last milestone, optimization. We evaluated it, then updated some parts, cleaned the data, optimized the prompt like that. It helped us for the last milestone. Also, observing the accuracy and latency helps evaluating or and optimizing, improving the AI agent for projects like that. So we can continue.
Just before that, I want to say there can be misunderstanding about accuracy. It's just about Mina documentation, evaluation about the verbal queries. Because of that, when we consider coding accuracy, our model much more powerful than ChatGPT-4, but there is no currently exact database. Because of that, we couldn't evaluate the coding performance. We just evaluate the documentation retrieval. Okay.
We have 3 minutes.
Huh?
We have 3 minutes.
Oh, okay. Okay, then there are some other AI tools, as you can see, Aptos, Solana, AvaGPT, StartNet. StartNet, they were building, but there is nothing there. AvaGPT, it's about the Avalanche. Solana, it's the best of them, but just getting official documentation, don't use tools, etc. And Aptos is same with Solana. In conclusion, our AI tool, I think, the best. Okay, quickly, I want to. As you can see, we have user interface and context integration. Also, there are explanation of these milestones. Our tools doing project planning, implementing, and we also optimized a lot. Okay, and future improvements, UI. We focused AI things. We focused to improve our AI. Because of that, we not focused enough the UI. We have to, or we need to develop UI for better looking. Also, there can be some UX problems, but now it's okay. Also, we processed the Discord data with GPT 3.5 because for in OpenAI API for GPT-4 was not working for very big databases. And also fine-tuning model for O1.js, also potential improvement areas. We have also future and side project ideas. We currently have Umstat API. If you don't want to use our applications, you can just posting a API request to our API. You can find information in the documentation. Discord Umstat, I explained already. Beginner template Umstat, it was Yunus's idea. It's like a teacher smart contract teacher AI. Also, I have a I have an idea, interactive learning platform like Crypto Zombies, but integrated with AI. Also, GPT, we can upload the Umstat to the GPT store. Special thanks to Mina Protocol zkIgnite program for funding the project. Also very special thanks to Yunus, Ilya, Philip, DFST, Santiago, Yasin, Will, Hazar for all feedbacks, motivations, and contributions. Now, Q&A time. Thank you for listening.
Yeah, congratulations, Berkin and Dokan. I think it was an amazing presentation, and
Yes.
like I love the part that you thanks everyone. It was like a live television show, so it's made me more professional. Just kidding. So yeah, like you receive lots of compliments. I think maybe there is one question I see from Mario is that's the reality. Like Mina and I mean at least O1GS has been changing very actively.
Yes.
So what is the plan like to keep Umstat updated within the time?
Uh, as I said before, we can update all data, all documentation data, and all Discord data with a few commands, and it will take some time, like 5 minutes or 10 minutes. And because of that, it is easy to update all data. We can update currently. It is, I think, no problem. But in this condition, please update the documentation. If you update documentation, we can update things.
Yeah, awesome. And also, I want to add, like, I really love the idea of AI teacher or like the interactive learning platform. So I am quite excited and keen to see the feature that you built with Umstat. And unfortunately, we need to continue with the other presentation because we are short on time. So thanks again, guys, and congratulations.
Thank you.
Thank you, everyone.
Okay, we'll continue with Gerçek Kriptocu. Are you there?
Hey,
Hello.
I'm
Yeah.
sharing my screen.
Sure.
Can you see?
Yes.
Okay. Hello, everyone. I'm Gerçek Kriptocu, content creator and YouTuber. As you know, I joined zkIgnite Cohort 2 with a community proposal called Educational Video and Podcast Series. And after a bit delay, I finally completed 1/4 of the milestones. But let's not forget that I will continue my video and podcast series even after I complete them all, because the community knows me and knows me with Mina, and I also love to produce content with Mina. So now let's take a look at some stats. Generally, I first upload the content to podcasts, then YouTube, and then to Twitter. In addition, I support it with my Telegram group. First, let's look at the stats of my videos. Then I will share the stats of the podcast and X with you. Let's start with first video. The first video is about Mina protocol. What is the Mina protocol? And it got 1.3K views. All stats from YouTube Studio. You can check from my channel. And here is the other stats. And the second video is about zcaps that you need to follow. And it got 4.7K views. Third video is about staking guide, Mina coin staking guide, and it got 4.2K views. And here is some other stats. And the last video is about hard fork, Mina hard fork. What will change with hard fork? It got 1.4K views in one day, and it still increased. By the way, I completed first quarter of milestones, and I will continue to produce more content. All Mina related videos on my YouTube channel you can see. And also I share all the videos and podcasts on X and Telegram. Here is my X stats. I got 3.3 million views in 28 days. You can check from that. I captured all the stats today. It's updated. We also started MinaCast, as you know, on Spotify. It's not good as others, but we will grow together, I believe in. But this is not end. Here is the upcoming video and podcast list. I will make an interview with One Lab CEO, Emre Tikişal, and then zkApp's promotion. I will choose the project from funded projects. Developer interview, Mina's vision, how to run a node, what is kimchi, and again zkApp promotion. And many more content will come. I will continue to engage with community. Thanks for listening.
Thanks, Gerçek Cryptocu. As this is like more about content, I mean, I wouldn't be lots of questions, and also I understand representation was short, but I really appreciate your engagement with the community and, you know, like being active in Twitter. So yeah, well done, and let's continue telling Mina to the world. Yeah.
Thank you.
Thanks. Okay, so normally next one is the StakeTab team, but I can't see them here because they may also like send a video afterwards. So let me check again, like, is there anyone from StakeTab here? Tuka or Vitaly? If not, let's continue with Mina NFT. Or Mikhail, are you ready? Mikhail? Yeah, all right.
Hi everyone.
Hello.
In my screen.
Yeah, sure. Yes, we see your screen.
Okay, perfect. So welcome to Mina NFT. The Mina NFT platform leverages the unique privacy characteristics of the Mina blockchain, and it combined with advanced AI technology. So it's main screen, and you can see many NFTs. Couple of those are by StakeTab, by the way. And you probably see familiar faces here. And it supports quite rich content, so you can put all kinds of the content inside the NFT. You can put some keys, you can put some text, you can put video, audio, and you can put PDF files. So basically everything that you would like to do. Every NFT can get one or many posts attached to it, and the post can have absolutely the same additional information, also the keys and so on. So let's now create some NFT. So first we need to choose some picture. Let's put picture to it, then let's name it. For example, demo 18. And we can put various public and private keys. So for example, let's say that demo key should be set to yes, and we want to set two private keys. One is S1 should be set to ABC, and second, for example, then we can choose should we pin it to IPFS of the metadata or Airwave for permanent storage. and press the Mint button. So now token metadata is being created. All the data that we decided to put it in NFT is being converted into the Merkle trees, Merkle maps, and the root of Merkle map is being calculated. Okay, it's calculated now and sent to backend for minting. Meantime, we can open the file with all the data and all the metadata, and it's got both public data and private data. And private data is marked as private. So it's stored on the user computer, and it's not public in this case. Okay, so while getting minted, in case we want to generate some image, we can use also our Telegram bot tool and can ask this Telegram bot to generate some image for NFT. So let's ask. Under the hood, Mina NFT has several models. ChatGPT for Turbo is the main model. Then DAL-E is the model that generates images. Whisper is a model that used for voice messages. And also some additional tools are being used, like elastic transponder, and Poly is being used for generating some voice messages. So totally the languages supported: English, Turkish, French, Italian, Spanish. Okay, so image is generated. Now let's create some NFT using this image. So let's ask what to create NFT demo test 3 with this picture that it just generated. And let's put the following keys: demo public key to true, and let's use the same keys as we did on frontend. So we're asking basically about what to do. Okay. And by the way, we see that the previous demo 18 was written. So we should just in a moment get some notice on our front end showing absolutely the same information that we just received. Yes. So we can open now. Yes, we see. We just minted NFT, and we can see transaction on Mina Block Explorer. This is pending now. Okay, so it's great. Now let's look what we can do with this NFT. Let's, for example, look what we can do with proofs. So we have keys, and we want to prove some keys. So I'm uploading here a JSON file with all the private information. And let's say that I want to prove two keys, demo and S2. So let's create proof. Let's see what will happen right now. Error, you see that NFT is not deployed. So the system is refusing to make any proof. Internally in the code, I do a lot of error checking and making sure that all state is correct. There is some overhead regarding it because basically I need to recalculate some Merkle trees, Merkle maps for it, but it's guarantees that everything is going in a correct way. And therefore, I would not would have some great errors. Also, to make sure that there are no errors, there is a system that controls and shows basically all that going on in the system, and I can see also all the errors. For example, if I will look what's happened during the last 7 days, I can see all the errors during debugging phase that I've got. Okay, so meantime, the meeting is going also on the on the Telegram, and let's now look at what parts Mina NFT composed of. So basically, the major part is the library, and all the contracts, all the TypeScript classes are in library. And there is API reference that has all the classes, and you can get all the information about you can call it and how you can use it. The coverage for the code right now it's at 80% for the general code, and if we speak about the contracts, it's at 99%. The second important part is backend. Backend is responsible for all the calculation of recursive proofs, for compiling calculations and so on. And because it's outsourced there, the front end it's quite light. So if we're speaking about the showing just NFTs and posts, O1.js library is not loaded, and it's very fast loaded. If we speak about creating proofs, O1.js library is loaded because we need to calculate a lot of stuff. Also for creating NFT, we need to load O1.js library, but all the compilation, all the proving is being done in front end. And as a result, we can do proving and verification even on quite light devices. So for example, if you would go to the main Mina NFT repo that also contains links to all other repos for backend, for command line interface 2, for documentation, for library, for example, and for front end, and go to screenshots, you can see that basically you can create proofs on mobile devices. And you can also verify proofs on mobile devices. There are other screenshots that you can be interested in. For example, you can look at screenshot with payment, its Stripe dashboard, its form where payment is being made, and so on and so on. Okay, so let's check what's going on with our transaction. It was applied, I guess. Let's check one more time. Can we create proof or not? Okay, this time the proof job was started, and proof is now being calculated. Let's check what's going on with our AI bot. Okay, so our test, we just got invoice for demo test 3, and our NFT is written to the Mina blockchain. Good. So let's now do something with keys. So we asked for some keys. So let's list keys for demo test 3 that we just created, and see what the keys are inside. Under the hood, the system is asking the backend for the keys, and the keys are encrypted with the key management service, with encryption key being held on AWS hardware devices, so they cannot be. Even I don't see this. It's okay. So those are list of keys. It's exactly what we asked to do. So let's now prove. I want to prove 2 keys, demo and S1. and let's see what will happen. Meantime, we can go and look at additional features. For example, there is onboarding system where you can give some information, and also billing system. So let's look what's going on with billing now. Okay, so we see that basically there are two jobs that we just started. And there is min job that just finished, and we can see the billing time for this job was 168 seconds. And also you can see that there are some jobs, for example, this one, MapProof calculate, its billing time it's 276 seconds, but job duration was less than this. It's because of the parallel processing. So when you calculate proofs that consist of more than one proof, everything is going in parallel. So the total billing time is higher than the job duration in this case. And at the end, we see total billing time for my account. That I minted 42 NFTs, and basically now I should pay to myself $400 for this. Okay, good. So let's now, yes, the proof job is still continues, and let's check what is doing our Telegram bot. Yes, Telegram bot is now processing it, and we just got proof. So let's look at it. It's a proof. I asked for two keys, demo, that is yes, and S2. And I got the proof that basically I can now verify. And yes, it's just normal proof. So let's verify it. How do we do it? We just go to proofs. And let's first verify it off-chain. So we got JSON files that I just shown, and we should upload it here. And there is information from this JSON file. So we're proving now for demo 18 with this address, two keys. There is no information, is it public or private, because it's not included. Let's verify it. So now it's handling. Okay, so verification job was sent to the backend, and we can wait for it. And meantime, let's go and see some example, for example, of how it can be done with the library. So let's look at this one, for example. So the library allows to create NFT with quite easy code. There are TypeScript classes that basically make everything quite easy. So first we should initialize. I'm working with test_vault2 because it's quite fast and good. Then we create some keys, and there are two keys. There is key for NFT address, and there is key for owner. The key for owner is not disclosed, and it's hashed when it's put on the state. And basically, to create our NFT, all we need is to write this line. We create a new NFT with name, owner, and address. It's all that we need. Then we're adding some text, we're adding some keys, we're adding some images, files, and we can add more complicated things like maps. So basically, it can be of nested any amount of levels. So you can create structures as complicated as you wish with many levels. We have 3 levels here. Then you should use name service. Name service is the main contract that's responsible for name management, both on backend and on the blockchain. And we're asking backend on this line to reserve the name, because we cannot use just any name, we need to reserve it. And if in case it's reserved, in case we succeeded, we basically getting confirmation and signature of the Oracle, names Oracle, that gives us the right to mint the NFT. Then we need to compile our contracts and basically just mint it, providing also the signature that we need. It's basically it. So let's do how it runs. So let me open some terminal, and we already minted several on test vault too. So let's, for example, do it on local blockchain. Test. So I run the code. We ping image, and it's basically the information with all the properties, with all the calculated Merkle roots and so on, both for image. We have a lot of information, and we see the here maps that contain additional information. So it's level 2, it's level 3, and we have a lot of keys. So now we're compiling the contracts, and as soon the contracts will be compiled, and of course cache is being used, we deploying name service, because on local blockchain, of course, it does not exist. So we need to make one more step here. We pinging to IPFS the data, and then it will be minted. Okay, so it's minted, transaction is sent, that's done. We got just new NFT with a few lines of code. Specifically, this file was just run. It's for local blockchain. The difference with the previous one is that basically name service is being deployed for the local blockchain, so it can be. Okay, so let's look what's going on in. Okay, we got our proofs. Let's download it now and open. Okay, those are proofs, and it's quite similar to the previous one. So let's now verify it on so we have two keys here, and we're now verifying on front end the proof that was created with our AI Telegram bot. And we have absolutely the same procedure as before on it. Okay, let's meantime return to the bot, and we can also sell our NFT. Let's say that we want $100. We just paid $400 for all the 40 NFTs we minted, so we need some cash back. And let's see what's happening. Okay, so we got our demo test 3, and it's now can be bought for $100. So if someone has $100, he can press, and basically he can get all the usual things you can enter. It's in test mode, so no money will be written off. Okay, proof verified, result true. So we got positive result on the proof that we basically just asked to verify. Good. So let's now move, and we of course got confirmation from our bot that it's on sale now. So we have something more. So we have additional front end we already seen, doc side we already seen. Example, we looked at it. AI tools we seen. So we basically let's look now how command line tool is working. So let's open it. Let's close this one. We don't need it anymore. And let's yes. So let's ask NFT to do something. Let's first ask for help and see what we can do. Okay, and here we have all kinds of things we can do. We can create accounts, we can check balances of accounts, we can reserve name, we can create NFT, index NFT, prove something, verify something, prepare redacted proof. Redacted means that you mask some part of text or image. And also there are some service comments where, for example, to put GVT for backend, to put GVT for IPFS, for Pinata, for Airwave, and it also can be encrypted, everything. So let's do something. For example, let's create one more NFT. So we put command create, and basically we didn't reserve the name. So first it's saying error loading name reservation data, and it's trying to reserve name, and we got positive is reserved true from the backend. So we can now proceed with the comments, and we have a lot of comments that we can add something to our NFT. So let's add, for example, key demo yes, key, let's do the same, ABC, and we're saying that it's private. It's to, and it's also private. Now let's put description for our NFT. This is created with Mina NFT play 2. Okay, and finally let's add image. We don't have a lot of time, so let's undo it. Let me check the name just a moment. Existing file. Okay. Okay, and let's do mint command. So it's now minting. It's all the backend and front end and command line interface tool. They're using the same library, but this time everything is compiled locally and handled locally. So we need to compile our contracts to prepare the transaction and send it. And it will not be indexed on the front end for the reason that we basically don't send anything to any information to backend or front end regarding this one. And therefore, after the transaction will be included in the block, we will need to call additional command saying that we want to index. Okay, so transaction is sent. We can now try to find it on mini scan. That's this one. Okay. Today was test period for testful 2. So in the morning, all the transactions were waiting in the mempool for a couple hours, and I put 2 Mina fee to be able to do it fast on the presentation. Otherwise, it will take much more time. Okay, so it's what we can do, and let's try to index it right now. Let's see what will happen if we try to index. So it's we're trying to index it right now, and okay, it's indexed. So let's return here. Yes, this one. So we just made a new NFT with command line interface too. Okay, Yasin, how many minutes do I left?
We have, yeah, we got one presentation late, so you have quite a time. So no worries.
Okay, good. Because I wanted to show more interesting things.
Yeah. Please, you can. We have time.
Okay, good. So this command line tool is basically designed in such a way that it can work offline. So in case you have really confidential information, it's really private, you don't want to disclose, you don't even risk of having it on computer connected to the internet, and you keep it only on a fly computer, you can use it for our NFTs and in fully private way. So let's look how it's basically work. I can use offline flag, and when I use offline flag, internet connection is not needed. Everything is being done without any internet. So I'm now trying to reserve a name offline too, and I'm using flag offline. And because it cannot be reserved, because internet cannot be used, it just asking me to copy this file to flash drive and to transfer it to online computer where it can be used with the helpers. So we have helpers here, and those helpers are designed to be used with offline tool. So let me find in the, yes, so I got in the request directory this request that just we created. Okay, and let's look what is request. The request is we want to reserve name offline too for public key that we generated also offline, and the private key is offline. And let's try to execute this request. So name reserved, and the new file we just got from the that confirms the registration of the name. It also contains signature. And what we should do now is we should transfer this file to offline computer to the data folder. So let's do it. Let's let me go to that. Okay. Okay, so I did it. I transferred this file that contains the signature to our offline computer. So let's continue. Let's now create NFT. And we also will do it in offline mode. Okay, so because we have information regarding the name already in our data directory on offline computer, it allows us to continue. So let's say that we want key offline yes. And we want key secret. And it should be private. And we want some image. Okay, everything is calculated. And mint. And basically the same, it will be request file that can be transferred to the web and sent for the mint. Okay, so now let's do more two interesting things. Let's go to documentation now, because I want to show two processes, but those two processes takes more than 1 hour, because it's needed around more than 100 proofs to be calculated. So what I did, I basically just did it before the presentation, and we'll show now just screenshots and what's going on to save time, because we don't have 1 hour to go through all this process fully. So let's say that you have some image file with some punk, and you want to prove that this punk has red hair. You don't want to disclose the face of the punk. You just want to disclose the hair. In our case, we have 50 by 50 pixels file, and we want to redact this part, the red one. So totally this file has 2,500 pixels, and we want to leave only pixels from 510 to 540 and 560 to 590. That's approximately it's the hair. So what we do, we create first a mask. So we say Mina NFT mask punk 1, it's name of the mask 510. So we mask those first 510 pixels, and we receive some masks. Then we add the second mask, and we have already 2 masks, and we add the third mask. So then we apply the mask to the file. So we're asking Mina NFT to redact or sanitize this image file by applying the mask punk 1, and we're saying that it's this format. So the result that we got. So it's original file with the face and everything, and it's basically only part of the file that shows. Now let's create a proof. So we're asking Mina NFT to create redacted proof. That means that we will prove only the areas that present in the redacted file, and we will not include any data or information about data that is not included in the redacted file. So we give this comment, redacted proof. We say that its format is PNG, and basically we have a redacted file that should be used as base for this calculation. So basically we extract all the information from these files, we load binary Merkle tree, calculate roots. To fit we need the height 13, and of course the ellipse number it's 2,500 approximately. We have some service fits, it's why it's a little bit higher. And we then created the proof. So we need to calculate 65 proofs because it's a number of pixels that we requested. And basically we need to calculate, it takes 12 minutes on my Macintosh. And then we need to merge, it takes 21 minutes. And we wrote the proof to this file. And we can then verify it. So to verify the proof, we need only the redacted file and the proof. we should not disclose, of course, the original file. So we say, let's verify the proof. We give information regarding the format of the file, and we given the redacted file that contains only red lines from the hash that we decided to disclose. And it's the file with proof. And one important thing is basically when you verify, when you create so many proofs, you need to have some way to understand that basically all the data that was fed to those proofs is the same as in the file. So what is going here, it's basically all the pixels are hashed and counted. And there are two fields in the public input. That one is count, and you see that basically you have count here, 65, and also it's public input. So you can verify that count of the pixels that they improved is the same as count of the pixels in redacted files. And second, all the pixels are hashed together, and you can calculate the same hash of those pixels, and it's also part of the public input of the proof. Then you have redacted root, and this redacted root is you can calculate because you have file. You just load binary tree from this file, and you calculate this redacted root, and you compare that it's the same and in the public input of the proof. And we left only one original root. It's basically root of the original file, and here we cannot verify it because we just verifying our file. So let's look what we can do to verify this original root. Let's go through the whole way on creating offline NFT. So we already did the first couple steps, and you're already familiar. So first we reserve the name. We execute the request to reserve the name. We receive signature for as confirmation of the reserving the name. Then we create NFT online. So we adding various secrets, descriptions, private text, images, and with the images, if we want it to be public, we also put IPFS hash of the images. So we should put in advance public images if we want to be visible to IPFS on online computer. It just provides this IPFS hash or Airwave hash, as the case can be, to our system. Then everything is being calculated, and we're also adding our file punk1 here. And in this case, we do not use no root options, so full Merkle tree is being calculated now and included in the system. And then we can mint this file by asking our front end to do it, and we're receiving the whole file with all data that is kept offline and encrypted if needed. And also we have here information about the punk file. So it's file, it's private. We have Merkle tree root, we have heights, MIME type, and so on and so on. So all the information that is needed. Now we mint it online in the same way as before, so you already seen it. And now we prove offline this redacted file. This time we use as a command. We use command proof PNG, and with given the name of our NFT that is named offline, and we get it somewhere here. This is offline one. Yes, this one. So it's the NFT that we now looking at. And it's going through the same problem, through the same process, but basically we now create several proofs, specifically 3 proofs, because if we going to look again to this information, the first, we need to prove that the punk data is present on a Merkle map, and we need to prove by providing witness that this root hash, that is root of Merkle map, that is being written to blockchain, and Merkle witness can be proved that they are okay. So basically, this root we can check on blockchain because it's part of the zk app state. So it's the first proof. We prove that actually this number is part of the Merkle map. Then we have some small Merkle tree that contains all this information regarding the, this one, regarding the punk, regarding the size, mine time, all that stuff. So we have Merkle tree. It's small, it contains only 14 elements, 14 fields, sorry, because some elements like storage field can take up to 3 fields. And we need to prove to go from this data that is root of this small Merkle tree to this root of the file. So it's the second proof that we generate. And the third proof we already seen in the previous conversation when we discussed creating a redacted proof for the redacted image files. Okay, so we mint it online. Generate proof. It takes a lot of time because this time we need to generate 3 proofs. And finally, we get in this proof JSON that contains all those proofs, and we can verify it online. Why online? Because this time we need information from the blockchain. We need to make sure that the root that is being used in public inputs of our proofs is the same as the root on the blockchain. So we cannot do it offline this time, but we need only redacted image file for it. So we're saying, okay, verify PNG. We want to use offline NFT. We want to verify punk file, and we provide also this file so it can be verified. So we verify all those 3 proofs, checking all the metadata, checking all those 3 proofs, and checking that the root is the same as on blockchain right now. And finally, if everything is passed, basically proof for the punk is valid and we receive confirmation. Okay, so it's basically, I think, all that I wanted to give in presentation. There are a lot of more information. There are many features. There are many contracts, data structures, information about front-end, API, Telegram bot, library. There are many languages supported, but if there are some questions on it, I can answer. But basically, it's all in the documentation. So you can go to documentation and you can see a lot of information and examples and so on about plugins. You can use badges to verify some data and so on and so on. And there are some also screenshots for the Telegram bot and specifications of all the functions that are being used under the hood. So basically you understand that it's very important to give quite good prompts to ChatGPT, so specifications of the functions can help you to understand exactly what's going under the hood and give specific and good prompts to the ChatGPT. And also information about all the commands for command line interface tools and so on and so on. And there are information on contract addresses. There are many contracts. They all deployed to testful2 network. It should be redeployed soon to updated Berkeley, I guess. And that's basically it. And I remind you that also in GitHub, you can get a lot of information. There are several repos with all those tools, and the main being Mina NFT that does not contain any code, just links and some screenshot and general description of what's going on. So I think it's all that I want to say right now. If there are any additional questions, I can answer.
First of all, really thank you for this comprehensive go through of the product and also the documentation. So I think it's an amazing work that you created, Mikhail. So I appreciate your efforts. And
okay, yeah, thank you very much, Yasin.
And are there any questions to Mikhail? Okay. So if not, we can continue with Pavel. Pavel, are you there?
Yes, and I invite everyone to visit Mina NFT site, Telegram bot, and just try. It's very easy. Most people prefer to use Telegram bot on statistics. Most NFTs are minted with Telegram bot, so just try, just play, just give me feedback, and I would be happy to look what's going on and to change something to improve based on the user experience. Yes, I know that I already have your NFT, Mario NFT, staked up NFTs, and actually there are many more NFTs. Talha created several ones. It's not listed here because I introduced breaking changes and cleaned several times all the NFTs, but totally more than 100 NFTs were created during all the time. Okay, thank you.
Actually, there's one question, like what are the pending features you will like to add or like planning to improve?
Okay, it depends upon the user feedback, actually. What I'm a little bit unsatisfied with is there are too many features right now and too many ways of handling. So it was my intentions to create many ways and then to see what will be important. Because, for example, for people who do not speak English or other languages and hardly can write, they can use voice prompts to create those NFTs and manage those. For corporations who are concerned about the security of the data, the feature with offline NFT creations can be of most importance. And what I would like to do is I would like to go into specific use cases and basically provide user interface designed for those specific use cases. And it can be done even by incorporating Mina NFT library usage into corporate systems. So for example, you can create NFTs for corporate transactions, not using those tools, but using Mina NFT library from the transaction processing system of the corporation. And it's the next most important thing for me. And the focus on supply chain. The focus is on educational NFT as proof of knowledge. And I thinking about giving cohort 3 proposal for educational NFTs to go into this direction. And that's basically it. So I think the next step is to make sure that it's fitted to the specific use cases and to make as easy and simple using of this project for those cases to make sure that there will be a lot of users in the system. Regarding the payments for the Mina, no, I don't have plans to add it, and I can explain why not. Because basically, from the KYC point of view, I have the same responsibilities as Mina Foundation, and we all know what kind of the onboarding process is Mina Foundation is doing for all the onboarding that is needed to get some Minas. And I'm not different. So basically, in accordance to the law, I have absolutely the same obligations, and I have experience with passing KYC, both on corporate and personal level, and I understand that it takes a lot. So basically, what I can do is I can use shared KYC, and I already had some conversation about this with several people from Mina Foundations and a lot of other discussions. So in case there will be provided some shared KYC for the people in Mina ecosystem, I would be more than happy to accept Mina on conditions that KYC will be passed and it will be some zero knowledge proof of passing this KYC. But anyway, I am responsible for FATCA and compliance rules according to the current legislation. So it's just too costly for me to get this KYC for NFT payments. It's the reason why only credit card are accepted right now.
Thanks. Thanks a lot. All right, let's continue with Pavel. Pavel, are you there?
Hello, are you hear me?
Yes.
Well, let's start.
Yes, we see your screen.
Okay. Well, now my teammate Sergey and I, Pavel, working on zkIgnite Cohort that help end user to prove their attributes without revealing any other information and provide as much privacy as possible. For example, you need to prove that you're an adult person with help of your passport, but without revealing any other information from there. And we're working on this solution. During what we plan to do on the zkIgnite Cohort 2, we built the car credential specification, create passport zk credential issuer, create initial zk credential SDK to manipulate and get zk credential, create domain-specific language to bridge compatibility between the zk proof system and user-friendly readable format. And also we built zk app to test the whole flow. Well, let's start with the key specification. Our team has developed specification that are suitable for different zero-knowledge proof systems. We write a standard zkIgnite, and also you can see the link to the specification and a bunch of attributes property in the car credential. Also create the key sure and as the library to communicate with the key sure and manage credential. We have the key credential zkIgnite Core on PNPM library, zkIgnite Mina for Mina developers. And also we've got Assure that you can see the code of the Assure on the link below. Also our zk passport passport zk credential can solve the Sybil problem and take part in the authentication process and so on. Well, here's an example of how to get our passport zk credential, and if you want, you can create your issuer, not only passport, or for example, a study degree credential and so on. All the things are described in library specification. To get the passport zk credential, you need to import two dependencies. For a Mina, you need wallet adapter, and for zkIgnite Core, you need HTTP some types and some constructor. To get issue instance, you need to pass endpoint to issuer, and that's it. You can get information from passport issuer. After that, you need to create wallet adapter. It's described here, and after that, you need to create a challenge request that includes information about subject identifier, when credential will be expired, and also the chain ID. After that, you can execute browser issue and get the passport credential. Also, we built abstract domain-specific language, JSON abstract language, which is Turing full language. It's designed to accommodate for various credential types, different queries, and to get a fully informed user consent. So here you can see an example of JAL program. We initialize our program, set target, which language it will be translated. It's in our case, it's the zk program from O1.js. Input schema, we in runtime we got a private variable and get a public static variable. After that, we set the bunch of commands. In this case, we've got assert, that's private variable and public variable are equal, and the translate result you can see on the right part of the screen. And O1.js JAL, you can see it on npm. Let's see all together. And the scenario is third-party application. Only the real people to participate in governments, and one person can vote in one time and no more. Thus, we provide a proof of personhood verification based on a passport key credential. After that, I prepare demo application that can show you the whole flow, what you can to build. Now we are on verifier front-end application, and we need to go through verification process. Verification process includes that we are a real person and that we are unique, and we want to take part in a vote. How does it work? We get the passport credential. Passport credential got a special property, attribute content identifier, and when we can verify the key credential passport attributes in circuit. We can calculate ATC in circuit, and set constraints that person is adult person, above 18, for example. So now we're on the verifier side. We need to get token to take part in the vote system. After that, we go to the subject front-end, connect to the wallet. Here's on the show program, we can see the JAL program that shows what verifier want to prove, and we are going to create a user-friendly representation of this JAL program. Well, after that, we need to get the credential. When we're done with KYC, we need to sign message. Here's the message, description, address, and so on. Sign in. So after that, we can see our credential. Here's our attributes, type when it was issued, when it's start to be valid until our public key identifier type of key, my properties, and so on. After that, we've got the proof. This is a signature proof to verify the whole attributes that our issuer with this key sign the whole attributes in a circuit. And we can verify the signature in the circuit. After that, we've got another type of proof. It's RC proof that is the hash of a bunch of attributes that provide document uniqueness in our case. So after that, we can go through verification. Now in the subject front-end application, we calculate appropriate proof to send it to the verifier, and after verification is done, we've got that we are verified, and we mint the token. It's our unique person token, and we can vote one time. For example, I want to vote for a blue. If we vote another time for a red, we've got that where we've already voted. So it's a good scenario, but what if I'm a bad person and I want to vote from another address? Well, I connect as from another address. I go through the whole process of getting the credential. Um, Well, after that we click on verify, we will not go through verification process because verifier already got our document unique identifier at C proof, and so we can't vote two times from two different addresses. So let's check verifier. So that's it. It's Sybil protection in action. Well, also we've got another approach to create verify proof. It's based on Merkle trees, and my teammate Sergey want to say a few words about it.
Yeah, thank you so much. That's gonna be short. Window, circle, share. It's a little addition when, like, after going through that program verification thing, we realized that maybe in practice all the queries are not that complicated, and it's just equality, arithmetic operations, and logical gates like and or. So we started with the IPLG model as the most simple thing. It's not. It's used in IPFS, for example. Basically, it's slightly restricted JSON. And if you have that kind of JSON in your possession, and if you calculate its Merkle root through like some convoluted process, you could do any kind of query against it. Like here, for example, the query is field A should be equal to 10, field B should be equal, greater or equal to 20. And yeah, everything is all right. Like just a single program gets executed. And you could do something like greater, just strict greater than 20. Run that. You see there is a query, like pretty logical query. And inside, while it's compiling, it uses recursive proof feature of O1.js proof system, so that every so-called atomic query like equals or greater than is executed independently and then rolled up to the resulting proof, like and the final one. And well, one nice thing about that is there is no way that a prover could cheat. Like basically, you should verify that you have a prover and a verifier use the same O1.js or Mina program, and that the query has been executed in exactly the same way as requested, and we have that in a form of so-called trace value. So it actually proves that your query has been executed correctly. You never know what's inside the private parameters. It just proves that the data that you have in your possession correspond to your query, kind of zero-knowledge database. And basically what we think could be good is to use every credential as sort of micro zero-knowledge database with queries executed against them using a single Mina program. So on that, I'm going to pass the torch to Pavel, or maybe you have some questions.
And also I'm going to show you the process of translation of the zk JAL program to the zk program on O1.js. So I've got test that we've got the O1.js JAL init program and Mina verifier program. Here's the same program that you saw on front end. Here's the constraint that public input equal private input. Also, here's a constraint that person is older than 18. And here's a huge attributes verification and @C proof verification. So we've got this JAL program and we can transform it to the zk program. It's not very development friendly, but it solves the problem about interpreting different programs in specific implementation. And that's it. If someone has the questions.
Awesome. Thanks. Thanks for an awesome presentation, Pavel and Sergey.
Thank you.
Yeah.
Are there any questions, guys, from the crowd? Seems like not for now. So yeah, thanks again. You receive good compliments. Mario says good project. Maybe I can ask a question. What do you plan for future? Like as the next steps for the product?
The obvious next step is to make it user friendly, like fully user friendly, where you actually store and like a bunch of credentials in a kind of more or less standard way, frictionless way. And kind of a side effect of that, an implication, is that makes third-party developers' life easier to integrate the credentials. So abstracting over complexity is the obvious next step. And well, I guess this is it, because this is a missing factor. Previously, we have been asked about like KYC providers, like issues with them. Apparently now we have Persona and another one. We got them in production, so that part is done. We have the credentials. We're fucking sure that the tech is solid. There is no leakage of information whatsoever. The next step is making it easier to integrate and find partners.
I see one more question from Mario. It says, what KYC tool are you using and cost for each case?
The one that you saw, the one that Pavel showed.
And where do you store credentials? One more.
So let's start with the KYC provider first. For now, it's Persona, the one that you saw on this presentation by Pavel. We got to their startup program. So now up to 500 credentials per like verifications per month is free for us, and then $1 for verification. Pretty good. Another one that we had to sign up for is Shufti Pro. This is slightly more expensive, I should say. Significantly more expensive, but it's all right, because we were not sure in Persona till the very last moment. And where do we store the credentials? For now, the storage is effectively a local database. And as long as it's encrypted and as long as we do not share that stuff, we shall be fine. Like, it's pretty standard approach. We could go with ceramic as a storage. To be honestly, we still evaluate that thing because we are not yet sure if we should disclose even private credentials without some additional measures to prevent disclosing meta information. Like if you publish something over the internet, even if it's encrypted, you still have a signal that, for example, you have that additional credential on your name. And that could be dangerous.
I definitely see it. Yeah. I agree with Mario a lot. Like, I think this is a good opportunity for other applications in the ecosystem for a use case too. So yeah, well done, guys. I appreciate your work.
Thank you.
Thank you.
All right. So last but not least for this session, we'll continue with Ilya when you're ready. Just for your information, in 20 minutes, I need to leave for the other session because like one presentation is overlapping, but Mete and Talha is here to cover me in 20 minutes. So yeah, Ilya, whenever you're ready, we can start with your presentation.
Sounds very good. Thank you. We can start now. I am waiting just for one more app to pre-compile, so in the browser, so we don't have to sit and wait for it long. I will begin by introducing myself and what the project is. So my name is Ilya. This is my fiance Yasmin. She's assisting for this presentation, and today I will be presenting zk locus. As I'm gonna okay, I need to grant permissions to share the screen.
You
So
should you should be already able to share your screen.
What?
You should be able to share your screen already. Yeah.
I believe the limitation is in. I've never shared the screen from Safari apparently, so I just need to quickly enable it.
Mm-hmm. If you have Chrome, it should be easier, like in Google Chrome.
Yeah, I guess I can rejoin from there. Give me just 1 minute.
Okay.
One moment, please. Thank you for your patience. This should work now.
Sure.
All right, perfect. So I'm going to share the entire screen. Okay, so first of all, I will begin with an overview of zkLocus and what were the deliverables of cohort 2 for zkLocus. So zkLocus allows for authenticated, private, and programmable geolocation sharing, both on-chain and off-chain. This presentation will, later in the presentation, we'll have a couple of live demos, and we'll be both generating the proofs locally and verifying them locally, and then submitting them onto the Mina blockchain on the Berkeley testnet. So besides the obvious deliverables of the code and the associated zero knowledge circuits, there's been quite a lot parallel. So the first thing is the homepage for the project. It outlines the features, presents an overview of the API, and also contains the link to everywhere you need, like the white paper, which is if you're interested in diving more deeply in and understanding how it works and how exactly on which aspects of Mina it relies and how exactly it achieves the goals, namely through the use of recursive zk snarks. I invite you to read it. It's quite a lengthy read, so I believe scheming will just scheming through it will go a long way. There is also a Twitter community with over 1,000 followers. That is the main contact page. That's where most of the contact and interactions with the community happen, and also the updates. There are also other community channels created, like Telegram, but I just haven't gotten to fully set up those. But they're coming within the next couple of weeks. Now, besides just the code of the project, there was also an additional tool developed. I call it the integration oracle, and we will actually see it in action in demo. And what the integration oracle is, it's an HTTPS service, and it essentially acts as an oracle for signed geolocation. I will speak more about what it does during the demo, because we're going to have a little bit of downtime while the proofs are generating and things are moving. So I'll cover it in more detail there. And of course, there's the main zkLocus repository. Although I realized that I haven't pushed about a week worth of commits, so there's more things here, but I mean not significantly more. So with that said, let's jump straight into the demo. This is going to be a multi-part demo. First, I'm gonna show you how you can use zkLocus to generate private proofs and what it actually means visually. And then we'll be sharing an exact geolocation, because zkLocus also allows for the exact geolocation coordinates to be shared. There's an addition here of not just geographical coordinates, but also arbitrary metadata. And we'll be submitting both of the proofs on chain. So let's first. So I'll explain what I've done here. The only thing that I did is click compile proofs. Now it usually takes around 5 minutes, I believe, because there is screen sharing and many apps open. Also, with switching tabs, it took 8 minutes. This can be further optimized, but this is not the main point of this demo. It's to demonstrate the usage. So with all of the proofs compiled, I'm going to explain you what happens. So everything that will be executed, nothing here is mocked. Everything is working live. So if things go wrong, I hope they won't. We're gonna have to wait for recompilation again. So in order to in order to authenticate the geolocation, as I mentioned, we're going to be using the integration oracle. And that's what this URL, this endpoint URL is symbolizing here. So you don't need to insert the correct one for it to work. And you can see it in action here. So what's actually happening, this is just an instance of it running. And when I make a test connection, as you see, it receives a request to send the coordinates. Now let me just change them so so we can test with something different. There you go. There's a different set after we remove the cursor. So this is what the integration oracle is. It's running locally, but it's designed to run as a part of any infrastructure. So the first thing that we will do is I clicked here on locate me. I'm just using the browser's API to identify the geolocation. And the first step to do is to authenticate our geolocation with the oracle. Now I have the console open here for a reason. I'm using, there's some relevant information that I'm going to mention during the presentation, but there's also a couple of debug messages which I haven't removed because I was debugging, and if something goes wrong, I'll know exactly what. So the first thing that I'm going to do is I'm going to create an authenticated proof of my geolocation. I'm going to click on authenticate geolocation, and as you can see here, it's currently making a request to the geolocation oracle. Well, it already did. If I go back to the terminal, it's been already done. However, what it's doing now actually is using the zkLocus zero knowledge circuits to authenticate an exact geolocation point using the oracle. Now, the main idea with Oracle is to provide for an easy and straightforward integration of zkLocus into any existing infrastructure, including legacy. For speaking a little bit about the motivation behind it, for anyone who has ever worked in enterprise will know very well that no matter how good the solution is, if it's unable to comply with 77 arbitrary internal policies, it's just not going to work. So the idea with the zkLocus Oracle, it's integration Oracle. It's an npm package, so you can install it from npm. You just do npm install zkLocus-oracle or do npx run zkLocus.oracle, and it just starts the server. So the idea with it is to enable for an arbitrary logic of geolocation authentication that works within the zero knowledge circuits. Now, if you put this on premises of, well, let's say an existing system that perhaps uses Java, MySQL databases, or Perl, Python, whatever is the case, this integration Oracle will allow for simple integration of arbitrary geolocation authentication logic within any infrastructure. So this is the idea with it. When you see, as we see here by the update in the console, the geolocation, the zero knowledge proof for the exact geolocation has already been proven. So right now, let's actually generate a private geolocation proof and what it actually means. Now, zkLocus works with triangles, with polygons more specifically, but with 3-point polygons. Now, there's nothing limiting it to work with only with polygons. However, you can represent anything with polygons. It's the most basic case. So I'm going to define one polygon, and I can actually click generate proof right now, and it's going to generate a proof for this, essentially proving that your authenticated geolocation point is within this polygon. But we'll do something a little bit more interesting. Thanks to the recursive zk-snarks architecture of zkLocus, it works as its own application chain, and it essentially allows for an infinite combination and compression of zkLocus proofs together. So what we'll actually do is, let's define this area. There's just arbitrary polygon. I'm just making sure that it's inside. and I'm going to click Generate Proof. Now, here on the screen, you will see a little bit more output. I will explain you precisely what is going. So the first thing that's going to happen is zkLocus is going to generate a zero-knowledge proof that this authenticated geolocation point is within this polygon. This generation is happening now. In the next step, it will generate another geolocation, another zero-knowledge proof that this same coordinate is now within this polygon. Now, after those two proofs are generated, it's going to combine them both together, essentially using a rollup or compression. Recursive zk-snarks passed through recursive zk-snarks in to speak more technically. And what this will effectively achieve is a proof that your geolocation point is within this area outlined by both of the triangles. So I'm not entirely sure how this shape is called mathematically, but I believe the visuals make it trivial to imagine that. So we already have the output of one of the proofs. You can see it here at the bottom. Now, I'm still waiting for the second one. So it generated one proof, it's going to generate another one, and then it's going to combine them together. So we care about the last proof, which we will verify below. So the main idea with these proofs is that in a one single proof, in one single public output, you incorporate the authentication of the geolocation as well as a private proof, private geolocation proof. If you're interested in learning more about recursive zk-snarks and how they work, I have actually written this. This was also as a part of the project's one of the artifacts. If you go to my blog at elya.blog, you will find here this blog post called "Recursive zk-snarks Proof as a Private Input: What is Visible to the Verifier." So this dives deep into how recursive zk-snarks work and also how zkLocus leverages them, and there's an example application. So if you're really interested in the technicalities, I'm highly inviting you to read this blog post. And I'm not just saying that just because I wrote it. We're almost done. It's a returning result of AND, meaning it has combined both of the proofs together. It combines them with AND logic. So as soon as the final proof, the final rolled up proof returns, we're going to be able to first verify it and see visually how it works. And then after that, we're going to use the Aura wallet to submit it onto the Berkeley testnet on Mina, and thus effectively bringing a private and authenticated proof onto the blockchain. If you go more onto the white paper, you can read more about the roadmap and the future plans of zkLocus, but one of the first steps after cohort 2, after today's presentation, is to actually expand deeply on the blockchain aspect of it, and also enable for value incentive programmability for the submission of proofs. In more simple terms, this would enable you to effectively set a bounty for a zkLocus proof that you want to be put on chain. And once that proof is put there, then you receive a certain amount of a token. There is the ZKL token, which is the token specific to zkLocus that is on the roadmap. And this hopefully this demo will illustrate you more into how it should function. So right now we have the generated proof JSON. If I paste it here, you can see that it's the same area. I believe it's slightly different zoom, but it's the same area. If we verify it, well, verify successfully. Now there's a little cheat code. So zkLocus is not only a set of zero knowledge circuits, there's also a friendly API associated with it. There are about 13,000 lines of code last time I counted, which was yesterday. And I believe about 5,000 or 6,000 of them are just from the API. So this gives you a perspective on how much importance was given to a user-friendly API. If I change anything about this proof, it's gonna fail. The reason why this verification is fast, verification is also fast, but here specifically, the way the API is designed, the proofs have actually already been verified and they're cached. I also implemented caching besides the O1JS caching. I've also implemented a custom caching layer on zkLocus. So right now we're gonna connect to our wallet. I've already connected to it. I previously deployed the contract at this address just to save time. And right now I'm gonna press on submit proof. Now the first thing that it will do is it will need to prove the transaction. So this is gonna take a couple of seconds. And after this, we can submit this proof onto the blockchain and and visualize it there. Regarding the API, if the API has pretty extensive documentation within the code. So if you would like to see some examples of how easy it is to use it, for example, let's go to the proof that the proof that we're currently generating and submitting. This uses a similar no, this is a test file, but it uses the demo uses logic very similar to this one. So in zkLocus, essentially the way the public API is designed is that everything works around your coordinates, which in the zkLocus API is called zkGeoPoint. My transaction is ready to be sent, so I'll click confirm. I'll come back to that on the next demo. So let's go back to the UI. And the transaction has been submitted. We can see it on the Mina scan IO. It sometimes takes a little bit of time to index it. Okay, it's already pending. And also if we go into the wallet, we can see pending here. I'm gonna go back to the API, but now I'm gonna go back to the second demo. So this demo now features an exact geolocation proof. So remember, with previous proof, we have submitted that my authenticated coordinates are somewhere within these two polygons. So essentially in the area outlined here. What we're gonna be doing in the second demo is generating and submitting a proof of the exact geolocation. So not private, but authenticated. Let's go to a city. Does someone have any city suggestion? Okay, I'm gonna use Paris. Let me just test the connection. It's using the same geolocation oracle, so I'm going to authenticate this geolocation with the oracle. And while it's authenticating, I'm gonna go back to the API. So in the public what I call the public API is the non-zero circuit one. It's the one located here in the API folder that abstracts away all of the zero knowledge aspects, all of the compilation, all of the proving, all of this is abstracted away. When designing the zkLocus API, I always had in mind this idea of being able to do anything within approximately 3 lines of code. I'm not really sure why 3 lines of code, but I guess when you subdivide this into the main points, you essentially have authenticating geolocation, then doing something with that point, and then proving it. It makes sense for it to be 3 lines of code. There's essentially 3 semantic steps involved. So in zkLocus, everything revolves around the GeoPoint instance. So in order to do anything zero knowledge related with your geographic point represented by latitude and longitude, you access the prove property, and then you run one of these methods. So there are several methods. They're being expanded pretty much every day. So this is the exposed public API proving set that exists now. And in order to authenticate the GeoPoint from Oracle, you just need this line of code. besides declaring the geopoint, which in my tests, I just use a random one always to following a property and randomized testing-based approach. So with one line, you authenticate your geopoint, and then in another line, this same geopoint, you can prove that it's within a specific polygon. And from there, well, you can verify the proof directly. You can convert it to JSON. You can do whatever you'd like with it. I'm going to go back to see the compilation hasn't finished yet. So I can show you how easy it is to do what we did right now, which is we didn't prove that the geolocation is in one polygon. We actually proved that it's within one or another. So actually both, right? Thus defining, essentially changing the proved area from a triangle to a different geometric shape. Once we have our first in polygon proof, we can, on the same geopoint, create another, create proof for another 3-point polygon or triangle. You can actually do it sequentially. You can just like do, because this returns the same object, so you can just actually chain it, and it will actually be achieved in 3 lines if you really want to, for any size of the proof. Once you've authenticated within the second geopolygon, well, you can now combine both with an end statement, and now you have a proof that encapsulates both of the other proofs. The geolocation has been authenticated now with the Oracle, and now I'm going to attach arbitrary metadata. So for this, I'm just going to type, hello, my name is Ilya, and I'm going to attach metadata. Now, I'm going to explain what exactly is happening here. So essentially, we have authenticated the geopoint with the Oracle. So now we have an authenticated geopoint proof. And now we're going to attach arbitrary metadata to it. Now, for the demo, I have included text, but you can use images, videos, links to websites, any other zk locus proofs, or any other zero-knowledge proofs. This metadata field essentially makes zk locus infinitely extendable. You can attach arbitrary metadata. And again, this can include zero-knowledge proofs. This can include on-chain state, whatever you want. Now, the idea is not to have this field to be used for everything. This is simply essentially a generic entry point. If you have a use case that is not currently covered in the zero-knowledge circuit implementation, you can use this field to achieve this result. And this also works quite well for media. So attaching metadata is quite a lot faster. Now we have the same type of proof, and we're gonna do the same verification. So I need to click verify proof. Okay, exact geolocation successfully verified. And let me just confirm that this is Paris, but because yeah, it is Paris. And again, if you change something and click verify, well, it does tell you here that on the console that the proof verification has failed, and you're not shown the point. And the metadata also, it's cryptographically attached to the proof. Now we're gonna connect to the wallet once again, and let's submit this transaction onto blockchain. Under the hood, metadata uses SHA-3 512, which was added when 01JS 0.15.1. And yeah, I took immediately advantage of that. This perfectly fit the use case that I was looking for. I actually had another implementation written, which uses Poseidon hashes and custom structs, but I've removed all of that code once it came out, and I just rewrote it in a much simpler and cleaner way. And also that obviously removes the need to test my own implementation. Once you have an exact geolocation, you can attach arbitrary proofs to it, and you can combine this with any other zk locus proof, thus creating an application chain or a rollup. I'm gonna confirm this transaction for the wallet, and once again, it's available on Mina.io. Now the second window is just Minascan asking me to connect the wallet. Okay, it says not found, but it's going to be shown in the wallet. Sometimes it takes a little bit to index. If you see you have the new transaction pending, it's still loading it, but if we go to the previous one, it should be confirmed. Oh, this is the first one, I believe, or no? Okay, well, both of the transactions will get on chain. They're real transactions. They're shown here in the wallet. Sometimes Minascan takes a little bit time to update. Now, before I finalize the presentation and go into questions, I would like to take a moment to thank some individuals who really assisted in this journey. Thank you very much, Yasin, Will. You've provided incredible support on the product side, and also with, well, essentially anywhere that required help. I was able to get very fast contact with the people. Also, thanks a lot to Mate. He is the technical mentor, and he assisted me a lot with some insights into O1.js and what is the best way to structure the code and the architecture. For anyone reading, for anyone watching this, I can give you the advice of look into using zk programs before using smart contracts. This allows you for essentially trivialize your smart contract setup. I will demonstrate you an example of a smart contract. The ones that were actually used are just this. That's it. So the magic happens, of course, in these proofs, right? That's the actual zero knowledge proofs. But it allows you to remove all of your logic off chain, and on the blockchain, essentially, you can design your application where it only requires one proof submission. Also, a big thank you to Yunus for the technical insights. And I'm not sure about the real name, but it's Tivio on Discord, specifically for assisting me with metadata implementation, alongside other technical discussions. And also the technical mentor, Patrick, provided me some very good guidance on how to structure the zk locus as a product. And I hope I haven't left out anyone. I will stop with the presentation. And if you have any questions, please let me know.
Thank you, Ilya, for your great presentation. I believe that there is some questions in the messages. I am there just asked some questions. Have you just answered them?
Yes. Also, I just realized that my the audio wasn't streaming into the earphone. So if somebody said something during the presentation, I didn't hear you. Okay.
No, you are fine. You are fine.
Okay. So how users look on. How can one verify corresponds to the actual physical location? How do you tell me? How do you think that the geolocation should be verified? It can be implemented into zk locus. It's whatever you want. I moved the pin outside, but I could have used my browser's geolocation. It doesn't need to use an oracle. It can use a hardware geolocation proof or some signed hardware proof, but I don't have access to any hardware component that is able to provide me with that proof. Now, if you do know of something, I can integrate it literally within an hour. It's very simple. All I have to do is write a wrapper circuit around it to return the specific public output that zk locus expects, which is called geopoint. If you look in the source code. So whether the user can or not manipulate their geolocation, the answer to that is yes and no. If you design if you use an authentication method that allows them to alter their geolocation at will, like I did here, then yes. If you use one that does not, then no. So again, the idea with this integration oracle, this is as simple as installing, running npm install and launching it. You can put it in your own infrastructure. Let's say have it running somewhere in Kubernetes, and maybe use custom authentication logic, whatever you want. Maybe you're looking up MySQL databases. Maybe you're looking up, running other parts of code. You can be looking at the IP address. Perhaps you can do a little ping test and see if the location seems more or less to be where the user is. And then you use it to sign with the geolocation oracle. Now, just to be very clear, this doesn't require an oracle. This is just I went for the simplest practical integration that could be done today. So if one of you comes and says, hey, I'd like to put this, use it in my project, use it within my infrastructure, it's a 1-hour job, for everything. It's 2 minutes on my local machine, but I'm assuming for some difficulties in integrating into any environment. I hope this answers your questions. If not, please let me know and I'll answer further. Okay, thank you.
Thank you so much, Ilya. That was a really great presentation for sure. And I wish you happiness with your fiance as well.
Thank you.
I will, looking forward to just get to your wedding day as well. If you just call us from on the Discord server, please do let us know about the wedding day.
Beautiful, 100%.
Yeah. So that was beautiful. So thank you so much. If you have any question, guys, you can just reach out to Ilya, I believe, on Discord as well. So yeah, you can just reach out to Yasin, Will, and Talha and me as well about any single questions that you have about cohort 3, cohort 2, and cohort 1 projects and the upcoming versions of them as well. So thank you so much. And one more question for you, Ilya. Are we invited to your wedding day?
100%. So there isn't a wedding day yet. As soon as I know, I'll let you know.
Okay. So thank you so much, guys.
Thank you.
Yes, Talha, can you hear me?
Yeah, I can hear you, but not healthy because I have some problems with my phone.
Okay. By the way, guys, for your information, both Talha and I, we just catch to these meeting just suddenly, and this is why we aren't prepared yet. But I believe that it was a nice meeting for sure, thanks to Yasin and Will. So yes, that was for all, I guess, for this meeting. So as I said again, please do let us know about any single thing that we can just help to you. Have a good night, evening, or midday. I don't know where you're from, but have a nice day.